Hello dear students, all of you welcome to Vidyan classes. Today we will discuss some problems using first 5 properties of inverse trigonometric functions. Elements of mathematics exercise 2 page number 61. Question number 1 7th bit. The value of sine tan inverse x plus tan inverse 1 by x greater than 0 is equal to dash 0 1 half. Answer, it is defined by tan inverse 1 by x is equal to cot inverse x if x greater than 0 and minus pi plus cot inverse x if x less than 0. Tan inverse 1 by x is equal to cot inverse x when x greater than 0 and its value is minus pi plus cot inverse x when x less than 0. Now sin tan inverse x plus tan inverse 1 by x, which is same as sin tan inverse x plus cot inverse x, which is equal to sin pi by 2. Since tan inverse x plus cot inverse x is equal to pi by 2. X belongs to set of real numbers. Tan inverse x plus cot inverse x. Tan inverse x plus cot inverse x is equal to pi by 2 when x belongs to R. So the value is 1. Clear? Tan inverse 1 by x is equal to cot inverse x if x greater than 0 and its value is minus pi plus cot inverse x when x less than 0. Sin tan inverse x, tan inverse 1 by x, which is equal to cot inverse x as x greater than 0. For x greater than 0, tan inverse 1 by x is equal to cot inverse x. Tan inverse x plus cot inverse x is equal to pi by 2 when x belongs to R. Sin pi by 2 is equal to 1. Clear? Okay. Next. So the correct option is 1. 1 is the correct option. 12th bit. Answer, let tan inverse 2 is equal to alpha and cot inverse 3 is equal to beta, which implies this. Tan inverse 2 is equal to alpha, cot inverse 3 is equal to beta, where alpha and beta are two radian angles. Since every inverse trigonometric functions represent a radian angle, tan alpha is equal to 2, cot beta is equal to 3. So square tan inverse 2 plus cos square cot inverse 3, which is same as square alpha plus cos square beta. Square alpha is equal to 1 plus tan square alpha, cos square beta is equal to 1 plus cot square beta, which is same as tan alpha is equal to 2, so it is 2 square plus one plus 3 square, which equal to 15. Five plus 10, that is equal to 15. So the correct option is 15. The correct option is 15. Is the answer. Method 2. Method 2. Square tan inverse 2 plus cos square cot inverse 3. Tan inverse 2 is alpha, cot inverse 3 is equal to beta, so it is square alpha plus cos square beta. Square alpha is equal to 1 plus tan square alpha, alpha means tan inverse 2. Cos square beta, 1 plus cot square beta, beta means cot inverse 3. 1 plus tan square theta is the same as whole square of tan theta. So it is written as tan inverse 2 whole square plus cot square beta is same as square of cot beta. Cot inverse 3 whole square, which is same as 1 plus 2 square plus 1 plus 3 square is equal to 15. Since tan inverse x is equal to x belongs to set of real numbers. Cot inverse x is equal to x belongs to set of real numbers. Square alpha plus cos square alpha, which is same as 1 plus tan square alpha, alpha means tan inverse 2. Cos square beta, 1 plus cot square beta, beta means cot inverse 3. Tan square theta is same as tan theta whole square, theta means tan inverse 2 or alpha. Similarly, cot inverse 3 is written as cot inverse 3 whole square. Tan inverse 2 is equal to 2, its square. 1 plus cot inverse 3, that is 3 square. So the result is 15. Clear? Okay. Note down. Note down. Next, 11th bit. Theta is equal to cos inverse x plus sin inverse x minus tan inverse x. x greater than or equal to 0, then the smallest interval in which theta lies is dash. Most important question. Let fx is equal to cos inverse x, gx is equal to sin inverse x, and hx is equal to tan inverse x. As x greater than equal to 0, dom f, that means domain of f, f means cos inverse x, fx is equal to cos inverse x, close bracket 0 1 close bracket. Domain of G is same as close bracket 0 1 close bracket, and dom H is close bracket 0 infinity open bracket. Dom theta. What is theta? Theta is equal to, that is dom fx plus gx minus hx, which same as dom f intersection dom g intersection dom h. Domain of fx plus gx minus hx is defined by dom of f intersection dom of g intersection dom of h. Dom of f close bracket 0 1 close bracket, intersection close bracket 0 1 close bracket, intersection close bracket 0 infinity open bracket. Dom of f 0 to 1, this region. Dom of f, dom of g 0 to 1, and dom of h 0 to infinity. The common region represent the domain of fx plus gx minus hx. That means cos inverse x plus sin inverse x minus tan inverse x. Domain of f in this region, domain of g in this region 0 to 1, but domain of h 0 to close bracket 0 to infinity, it is the common region. So domain of f plus g plus h minus h is same as dom of f intersection, it is defined by domain of f plus g minus h is same as dom of f intersection dom of g intersection dom of h. So the intersection region is, which is same as close bracket 0 1. Domain of theta is close bracket 0 1, which is same as relation of x, so that x greater than equal to 0 less than equal to 1. It is the domain of theta. We have to find out the smallest interval in which theta lies. Domain of theta is this. In this interval, theta is exist. In this interval, theta belongs to close bracket 0, 1. Domain of theta. Theta is equal to cos inverse x plus sin inverse x minus tan inverse x. Sin inverse x plus cos inverse x is equal to pi by 2. It is pi by 2 minus tan inverse x. Clear? Since sin inverse x plus cos inverse x is equal to pi by 2, x mod less than or equal to 1. That is x greater than equal to minus 1 less than equal to plus 1. Which implies this. Tan inverse x is equal to pi by 2 minus theta, which implies this x is equal to tan pi by 2 minus theta. Tan 90 minus theta is equal to cot theta. Dom of theta is close bracket 0, 1 close bracket. That means x greater than equal to 0, less than equal to 1. Since x greater than equal to 0, less than equal to 1, which implies this 0 less than equal to what is x? That is cot theta. Less than equal to 1. Which implies this x is equal to cot theta. Cot inverse 0 greater than equal to cot inverse cot theta greater than equal to cot inverse 1. Since cot is a decreasing function, cot theta greater than equal to 0, less than equal to 1, but cot inverse 0 greater than cot inverse cot theta greater than equal to cot inverse 1, as cot is a decreasing function. Tan is increasing and cot is decreasing. When x greater than equal to 0, less than equal to 1. When x greater than equal to 0, less than equal to 1. Cot inverse 0, that which implies s pi by 2. Cot inverse cot theta greater than equal to theta. Cot inverse 1 is equal to pi by 4. Cot inverse 1, which angle of theta? Which angle? Cot inverse 1 represent a radian angle. Which angle of cot? That belongs to open bracket 0 pi, gives value 1, that is pi by 4. Which implies this theta greater than equal to pi by 4, less than equal to pi by 2. Which implies this theta belongs to close bracket theta belongs to close bracket pi by 4, pi by 2 close bracket. is the smallest interval in which theta lies. First option, second option, third option. The answer is not given. It is the correct option. The fourth option, that is close bracket pi by 4 pi by 2 close bracket. It is the correct option. It is an entrance question. Theta is the smallest interval. That interval is close bracket pi by 4 pi by 2 close bracket, in which theta is equal to cos inverse x plus sin inverse x minus tan inverse x greater than equal to 0. It is the smallest interval. Clear? Theta is given by cos inverse x plus sin inverse x minus tan inverse x. X greater than equal to 0. Let fx is equal to cos inverse x. It is taken as sin inverse x. It is taken as tan inverse. Hx is tan inverse x is taken as hx. As x greater than equal to 0, term of f, that means cos inverse x. As x greater than equal to 0, term of f close bracket 0 1 close bracket, term of g close bracket 0 1 close bracket, and term of h close bracket 0 infinity open bracket. Theta is equal to cos inverse x plus sin inverse x minus tan inverse x. So term of theta means term of fx plus gx minus hx. But it is defined by term of fx plus gx minus hx is the same as term of f intersection term of g intersection term of h. Term of f is equal to this, term of g is equal to this, term of h is equal to this. Term of f varies from 0 to 1. Term of g varies from 0 to 1. But term of h varies from 0 to infinity. But the common region represents the domain of theta. Since theta is this, theta is equal to fx plus gx minus h. Domain of theta means domain of this intersection, domain of this intersection, domain of tan inverse x. So the common domain represents the domain of theta. The common domain represents the domain of theta. Since theta is the sum of three functions, sum of this and this and this. Clear? Theta is equal to cos inverse x plus sin inverse x minus tan inverse x. Sin inverse x plus cos inverse x is equal to pi by 2. So theta is equal to pi by 2 minus tan inverse x, or tan inverse x is equal to pi by 2 minus theta. X is equal to tan pi by 2 minus theta is equal to cot theta. As x greater than equal to 0 less than equal to 1, 0 less than equal to x means cot theta less than equal to 1. Taking cot inverse everywhere, it gives cot inverse 0 greater than equal to cot inverse cot theta greater than equal to cot inverse 1. As cot is a decreasing function. Decreasing function means the value decreases with the increase of theta. Here cot inverse 0 represent an angle. That angle is pi by 2. Cot inverse 1 represent angle. That is pi by 4. Cot inverse cot theta is equal to theta. Theta greater than equal to pi by 4 less than equal to pi by 2. So theta belongs to close bracket pi by 4 pi by 2 open close bracket. So the correct option is not given in answer sheet. So it will be the correct answer. Close bracket pi by 4 pi by 2 close bracket. Clear? Clear? Okay, note down. Next, question number 1, first bit. If a is equal to tan inverse x, then the value of sin 2a is equal to dash. Giving a is equal to tan inverse x, which implies by x is equal to tan a. Sin 2a is equal to 2 tan a divided by 1 plus tan square a, which is same as tan a is equal to x, so it is x divided by 2x divided by 1 plus s square. So the correct option is the 2x divided by 1 plus s square. Second bit, question number 1, second bit. If the value of sin inverse x is equal to pi by 5 for some x belongs to open bracket minus 1 open bracket, then the value of cos inverse x is equal to dash. Sin inverse x plus cos inverse x is equal to pi by 2 when x belongs to close bracket minus 1 close bracket. It is also true for x belongs to open bracket minus 1 open bracket, as open bracket minus 1 subset of close bracket minus 1 close bracket. Sin inverse x plus cos inverse x is equal to pi by 2 when x belongs to this set. Since this set is a subset of this, the statement is also true for x belongs to open bracket minus 1 open bracket. Sin inverse x plus cos inverse x is equal to pi by 2. So cos inverse x is equal to pi by 2 minus sin inverse x. Sin inverse x is equal to pi by 5. Pi by 2 minus pi by 5, which is same as 5 pi minus 2 pi, that is equal to 3 pi by 10. Therefore, cos inverse x is equal to 3 pi by 10. So the correct option is 3 pi by 10. Clear? Okay. Ninth bit. Cut inverse root of 1 minus sin x plus root of 1 plus sin x whole divided by 1 root of 1 minus sin x minus root of 1 plus sin x is equal to dash. Cut inverse root of 1 minus sin x plus root of 1 plus sin x divided by root of 1 minus sin x minus root of 1 plus sin x, which is same as cut inverse root of 1 minus sin x root of 1 plus sin x whole square divided by 1 minus sin x minus 1 plus sin x. Multiplying root of 1 minus sin x plus root of 1 plus sin x in numerator and denominator, which gives root of 1 minus sin x plus root of 1 plus sin x whole square divided by 1 minus sin x minus of 1 plus sin x. Multiplying root of 1 minus sin x plus root of 1 plus sin x in numerator and denominator. Multiplying this factor in numerator and denominator, which gives whole square of this gives 1 minus sin x plus 1 plus sin x plus 2 into root of 1 minus sin square x whole divided by 1 cancel, that is g minus 2 sin x. Sin x cancel, which is same as cut inverse two plus 2 cos x. 1 minus sin square x is equal to cos square x, root of cos square x, that is cos x, divided by minus 2 sin x, which is same as cut inverse 1 plus cos x divided by minus sin x. 2 cancel, which is same as 1 plus cos x. 1 plus cos x is equal to 2 cos square x by 2. 2 cos square x by 2 divided by minus 2 sin x by 2 into cos x by 2, which is same as cut inverse cos cancel, cos x by 2 cancel, 2 cancel, that is minus cot x by 2. Cut inverse minus cot x by 2. Cut inverse minus cot x by 2, which is the same as cot pi minus x by 2. Which is same as pi minus x by 2. Since cot inverse cot x is equal to x, when x greater than 0, less than pi. cot inverse cot x is equal to x when x greater than 0 less than pi by 2. Cot inverse cot pi by 2 minus x by 2 is equal to pi minus x by 2. Pi minus x by 2 is greater than 0 less than pi. Clear? Clear? Okay, note down. Next, elements of mathematics, page number 62, exercise 2, question number 2. Write whether the following statements are true or false. Answer. Sin inverse 1 by x is equal to cosec inverse x if mod of x greater than or equal to 1. Sin inverse 1 by x into cosec inverse x is the same as cosec inverse x into cosec inverse x, which is same as cosec inverse x whole square, not equal to 1. Since cosec inverse x belongs to x mod greater than equal to 1, that is x belongs to open bracket minus infinity minus 1 union close bracket 1 infinity open bracket. This is same as this. Cosec inverse x, the principal value of cosec inverse x close bracket minus pi by 2 0 open bracket union open bracket 0 pi by 2 close bracket. Since cosec inverse x belongs to this set, no value of cosec inverse x in this set whose square is equal to 1. Cosec inverse x is never equal to 1 in this interval. So square of cosec inverse x not equal to 1. Therefore, sin inverse 1 by x into cosec inverse x is equal to 1 is false. Cosec inverse x is never equal to 1 in this interval or minus 1. So square of cosec inverse x not equal to 1. Sin inverse 1 by x into cosec inverse x is equal to 1 is false. Clear? Okay. Next, third bit. Cot inverse minus 3 by 4 is equal to pi minus cot inverse 3 by 4. Since cot inverse minus x is equal to pi minus cot inverse x for all x belongs to set of real numbers. Cot inverse minus x is equal to pi minus cot inverse x when x belongs to set of real numbers. So cot inverse minus 3 by 4 is equal to pi minus cot inverse 3 by 4, which is same as pi minus tan inverse 4 by 3. Since tan inverse 1 by x is equal to cot inverse x when x greater than 0. One by 3 by 4 is equal to 4 by 3 greater than 0. Tan inverse 4 by 3 is equal to cot inverse 3 by 4. Since 3 by 4 is greater than 1 by 3 by 4, 3 by 4 greater than 0. Tan inverse 1 by x is equal to cot inverse 3 by 4. Clear? Tan inverse 1 by x is equal to cot inverse x when x greater than 0. Tan inverse 4 by 3, which is same as 1 divided by 3 by 4. The value of x is 3 by 4. 3 by 4 greater than 0. So tan inverse 1 by x is equal to cot inverse x when x greater than 0. So tan inverse 4 by 3 is equal to cot inverse 3 by 4. Now tan inverse 4 by 3 plus cot inverse minus 3 by 4, which is same as tan inverse 4 by 3 plus pi minus tan inverse 4 by 3, which is same as pi. Therefore, tan inverse 4 by 3 plus cot inverse minus 3 by 4 is equal to pi is true. Clear? Okay, next. Sec inverse x and cosec inverse x are exist for mod of x greater than or equal to 1. That means x belongs to open bracket. X belongs to open bracket minus infinity minus 1 union 1 to infinity. Sec inverse x and cosec inverse x are exist for mod of x greater than equal to 1. Mod of x greater than equal to 1 is the same as x belongs to this set. X is equal to half does not belongs to open bracket minus infinity minus 1 close bracket union close bracket 1 infinity open bracket implies sec inverse half and cosec inverse half are not exists. Clear? Half does not belongs to this interval or this set. Therefore, sec inverse half plus cosec inverse half is equal to pi by 2 is false. Clear? Sec inverse half plus cosec inverse half is equal to pi by 2 is false. It is a false statement. Tan inverse 4 by 3 plus cot inverse minus 3 by 5, minus 3 by 4 is pi is true. And sin inverse 1 by x into cosec inverse x is equal to 1 is false. Clear? Most important thing, what are the domain of the given functions? At what condition sec inverse x, cosec inverse x are exist? Sin inverse x, cosec inverse x, tan inverse x, sec inverse x are exist. What are the domain? In which interval the functions, the functions are invertible. Most important thing. You have to memorize the domain of the inverse trigonometric functions and the principal values of all inverse trigonometric functions. Then it will be easy. Sec inverse x and cosec inverse x are exist at this condition. Since sec inverse half does not exist and cosec inverse half does not exist, as half not belongs to this set. So sec inverse half plus cosec inverse half is equal to pi by 2 is a false statement. Clear? Okay. Note down. Next, elements of mathematics, exercise 2, page number 62. Question number 2. Write whether the following statements are true or false. Sec inverse minus 7 by 5 is equal to pi minus cos inverse 5 by 7. Sec inverse minus x is equal to pi minus sec inverse x. Where x mod greater than or equal to 1. Sec inverse minus x is equal to pi minus sec inverse x when mod of x greater than or equal to 1. So, sec inverse minus 7 by 5 is equal to pi minus sec inverse 7 by 5. Mod of 7 by 5 is equal to 7 by 5 greater than 1. Sec inverse minus 7 by 5 is equal to pi minus sec inverse 7 by 5, which implies as sec inverse minus 7 by 5 is equal to pi minus cos inverse 5 by 7. Since cos inverse 1 by x is equal to sec inverse x. Cos inverse 5 by 7 is equal to sec inverse 7 by 5. Since cos inverse 1 by x is equal to sec inverse x, x mod greater than or equal to 1. X means 7 by 5. Cos inverse 1 by x is equal to sec inverse x, where mod of x greater than or equal to 1. Therefore, the given statement is true. Sec inverse minus 7 by 5 is equal to pi minus cos inverse 5 by 7. The given statement is true. Next, question number 2, sixth bit. Tan inverse tan x is equal to x. When x belongs to open bracket minus pi by 2 plus pi by 2 open bracket. Tan inverse tan x is equal to x when x belongs to open bracket minus pi by 2 plus pi by 2 open bracket. It is given by tan inverse tan 3 is equal to 3. Here 3 does not belongs to open bracket minus pi by 2 plus pi by 2 open bracket. As pi by 2 greater than 1 less than 2. So 3 does not belongs to this set. Therefore, tan inverse tan 3 is equal to 3 is a false statement. It is a false statement. Tan inverse tan x equal to x, where x belongs to open bracket minus pi by 2 plus pi by 2 open bracket tan inverse tan x equal to 3. Here 3 does not belongs to this set, as pi by 2 greater than 1 less than 2. Therefore, tan inverse tan 3 is equal to 3 is a false statement. Next, question number 2, 8th bit. Cot inverse minus root 3 lies in second quadrant. Cot inverse minus root 3 lies in second quadrant. Cot inverse minus root 3 is the same as pi minus cot inverse root 3. Since cot inverse minus x is equal to pi minus cot inverse x. Cot inverse minus x is equal to where x belongs to real set of real numbers. cot inverse minus root 3 is equal to pi minus of cot inverse root 3. Since cot inverse minus x is equal to pi minus cot inverse x, which implies yes, cot inverse minus root 3 is equal to pi minus cot inverse root 3. Which angle of cot? That belongs to open bracket 0 to pi having value root 3, that is pi by 6. Tan inverse 1 by root 3 is equal to 30 degree. Cot inverse root 3 is also 30 degree. Cot inverse 1 by root 3 is equal to tan inverse 1 by root 3 is equal to cot inverse root 3, which is equal to 5 pi by 6 belongs to open bracket pi by 2 pi open bracket. It represents the second quadrant. It represents the second quadrant. Therefore, cot inverse minus root 3 lies in the second quadrant is true. The given statement is true. Clear? Cot inverse minus x is equal to pi minus cot inverse x. So we can write cot inverse minus root 3 is equal to pi minus cot inverse root 3. Cot inverse minus root 3 is equal to pi minus cot inverse root 3 is equal to 30 degree, that means pi by 6, which represent 5 pi by 6 belongs to open bracket pi by 2 pi open bracket. This set represent the second quadrant. Therefore, cot inverse minus root 3 lies in second quadrant is true. Next, question number 2, 12th bit. The equation tan inverse cot x is equal to 2x has exactly two real solutions. The equation tan inverse cot x is equal to 2x has exactly two real solutions. Tan inverse cot x is equal to 2x, which implies yes, cot x is equal to tan 2x, which implies yes, 1 by tan x is equal to 2 tan x divided by 1 minus tan square x. Tan inverse cot x is equal to 2x. Cot x is equal to tan 2x. Cot x is the same as 1 by tan x. Tan 2x is the same as 2 tan x divided by 1 minus tan square x. By the cross multiplication, 1 minus tan square x is equal to 2 tan square x. Clear? Okay. 3 tan square x is equal to 1, which implies yes, tan square x is equal to 1 by 3, which implies yes, tan x is equal to plus or minus 1 by root 3, which implies yes, x is equal to tan inverse 1 by root 3 or tan inverse minus 1 by root 3. Tan inverse 1 by root 3 is 30 degree, pi by 6, or tan inverse minus 1 by root 3 is equal to minus pi by 6. Since tan inverse x tan inverse x greater than minus pi by 2 less than plus pi by 2. Therefore, tan inverse cot x is equal to 2x as exactly 2 real solutions. Is a true statement. Is a true statement. Clear? Tan inverse cot 2x is equal to 2x has exactly 2 real solutions. Exactly 2 real solutions is a true statement. Tan inverse cot x is equal to 2x, cot x is equal to tan 2x, cot x is the same as 1 by tan x, tan 2x is equal to 2 tan x divided by 1 minus tan square x. 1 by the cross multiplication 1 minus tan square x is equal to 2 tan square x, which implies 3 tan square x is equal to 1, tan square x is equal to 1 by 3, tan x is equal to plus or minus 1 by root 3, x is equal to tan inverse 1 by 3 root 3 or tan inverse minus 1 by root 3. Tan inverse 1 by root 3 represent 30 degree, that means pi by 6. Tan inverse minus 1 by root 3 is equal to minus pi by 6. Since tan inverse x lies between minus pi by 2 to plus pi by 2. Therefore, tan inverse cot x is equal to 2x has exactly 2 real solution, is a true statement. Clear? Are you clear? Okay. Note down.